Hello everybody. In this video we'll present the major improvements of STRAP 2021 and AutoSTRAP 2021. Let's start with AutoSTRAP. Most of the improvements in AutoSTRAP 2021 are related to importing an IFC file from a BIM software and exporting to STRAP for analysis and design. We'll demonstrate the improvements with the following example. Let's import an IFC file. We can see a 3D model of the IFC file in AutoSTRAP's IFC model window. At this stage, certain elements in the IFC model can be removed or converted. IFC levels can be revised, and more. The toolbar display is improved, and the following display options are added. Isometric view, a 90 degrees rotation around all three global axes. We added 4 options for removing structural elements from the IFC view: beam elements, slabs, walls, connection plates, and removed structural elements. Let's see an example for removing the pile foundation. Select Remove and select the piles. The piles are removed and won't be included in the STRAP model. By clicking Display on Display Removed Elements, we can see the removed piles. Another option is to display the levels defined in the IFC file. At this stage, levels can be added, revised, or removed. Click Levels to open the Levels menu. To remove a level, click the level and select Remove. We'll add a level at the wall's top level. Click Insert and insert a level's name. Top in our example. The level height might be inserted manually or by pick face or pick point. We'll select pick face and select the wall's face at the top level. We can see the added level in the list and graphically when displaying levels. The display can be limited by coordinates. The coordinates can be limited by selecting points or by levels. Let's limit the display to level 3. The display limits can be inserted manually according to the global axis. Clicking Continue will take us to AutoSTRAP for revising the imported structural elements, such as beam sections, wall opening, slab thickness, and all the known features of AutoSTRAP. A major improvement is the ability to return to the IFC model by clicking IFC View. For this example, we'll remove the beams on the structure's perimeter. Select Remove individual elements and select the beams. Return to AutoSTRAP and we can see that the removed beams are not included. We'll now create a STRAP model. Click STRAP and then create a model. We can see the STRAP model for analysis and design. We'll move on to the general improvements in STRAP 2021. Selected options in the toolbar are displayed as pressed if active. For example, node numbers, beam numbers, and so on. The line width of different elements can be revised. In this example, the line width of walls is set to 2 pixels. To revise the line width, go to the Models tab, Setup, Miscellaneous, Screen Graphics, and Line Width. We can see the options for geometry, loads, and results. Walls can be displayed as filled with color and opacity. From the Models tab, Setup, Miscellaneous, Screen Graphics, and check Fill Walls and set the opacity percentage. When displaying beam end conditions, the program displays torsion release and axial force release. The restraints symbols display is revised. We can see the revised symbol for fixed restraint, pinned, and so on. Right-click on a restraint node, and Data for Node will display the restraint degrees of freedom. The default setting for limit display to a plane can be now revised. From the Models tab, go to Setup, Miscellaneous, and the Additional tab. Under Limit Display to a Plane, the default settings can be revised. In the Nodes selection window, a new option for Select Only Unrestrained Nodes is added. We'll move on to the improvements in the Geometry module. We added an option to delete a part of the model that includes different types of elements. Under Copy Delete, select Delete Part. Select the types of elements to be deleted, and select Nodes. Curved wall sections can be combined to a single design unit. Let's see an example. Select the wall section and click Define Revise. Next, go to Design Units and combine all the segments along the curved section. Different design units definitions can be assigned for moment or for shear. A new table with wall segment numbers can be displayed. From the Geometry tab, go to Output, Display Wall Data, Segment Indexes. For slab element, mesh angle can be defined. In this example, we'll define a slab with a mesh angle. Select Slabs and then Define. The mesh angle can be inserted manually or by selecting Nodes. Clicking Pick will allow us to select 2 nodes for the angle definition. Now define the mesh contour. And we can see the mesh angle. Restraints along the slab edges can be defined. Under Releases, restrain selected slab edges. Select the edges to be restrained and select the restraint type. The gray color restraints are assigned to the slab. If we want to remove them, we must select Releases again, remove releases from selected slab edges, and select the slab edges. When defining a submodel by selecting a part of the model, the connection type can be selected. We added an option to select a construction stage for dynamic analysis. Under Stages, select the stage for dynamic analysis. We'll elaborate more about this option when we'll talk about the improvements in dynamics. When exporting an IFC file from STRAP, vertical or inclined mesh surfaces are also exported. Let's see an example. Go to File, create an IFC file. We'll now open the IFC file with our IFC viewer. And we can see the vertical walls of the exported tank. When selecting Model Wizard as a method of creating a model, the whole process is improved. And additional drawings are added. For beams offsets, we added several commands, and the definition menu is revised. These commands are designed for revising an analytical STRAP model that was created with an IFC file via AutoSTRAP. When creating a model via AutoSTRAP, the structural elements are created at their original coordinates. Offsets are used to allow the program to connect elements, but to keep them at their original coordinates. In render view, we can see the elements at their original coordinates. In this example, we can see that offsets are assigned to the diagonals with property number 4. Under Beams, Offsets, the following commands were added. Remove all offsets at a node, replace beam end node, and change end node location. By selecting Remove all offsets at nodes and selecting nodes, we can see that the nodes keep their coordinates and all the beam offsets are deleted at the selected nodes. For the next example, we'll look at the connection node between a beam in a blue color and a column in red color. The column is connected to the beam's end node, and offset is assigned to the column to maintain its original coordinates. If we'll delete the offset now, the column will not keep its original coordinates and will be connected to the node diagonally between the column nodes. Let's change the end node location. Select Change End Node Location. Select the node, and then select the column. We can see that the node is moved to the column's end, and a new offset is assigned to the beam to maintain its original location. If needed, now the offsets can be deleted at the node, and the column will maintain its vertical alignment, and all the offsets are deleted. The command replace beam end node allows to replace the beam end node, but to maintain its original location by assigning a new offset automatically. In the following example, the diagonal, in orange color, is connected to the bottom node with an offset. We'll replace the beam end node. Select Replace Beam End node, select the beam end, and select the new end node. We can see that the diagonal is now connected to the new end node, and an offset is assigned to the beam end to maintain the diagonal's location. Pay attention. The new commands Replace Beam End Node and Change End Load Location maintain the beam's original coordinates. Only the beam offsets are changing. We'll move on to the improvements in the Loads module. We added a new option for the definition of wall loads. Within a load case, click Wall Loads, and three options are available: self-weight, area load, and align load. Area load is used for area loads to the wall's segments. Select the load direction, its value, and apply the load to the entire wall, or apply it on selected segments. We'll apply 0.15 ton per square meter in the x1 direction on the entire wall section. The area load is displayed as a line with arrows in the load's direction. Line load is used to apply line load at the wall's top level. In this example, we'll apply -5 ton per meter length in the x3 direction on selected wall segments. Select both segments, and we can see the line load at the top level of the selected segments. When selecting an existing load case, the program displayed the load case in the main display menu. We added an option to define self-weight on all elements with one command. We'll define a new load case, and in any of the load types, joint, beam, elements, etc., there is the self-weight command. This command allows to define self-weight for the entire model. In this example, we'll insert a factor of -1 in the x3 direction, the height axis. After clicking OK, we can see the self-weight for the entire model. Another improvement in the Loads module is the option to display a DXF file in the background. Additionally, the DXF points can be used for the definition of global loads locations. In the Loads module, go to Display, DXF Drawing, Load a DXF Drawing. Select the DXF file, and we can see the drawing in the background. Now let's define a new load case, and we'll define the global load. The load is -0.4 ton per square meter in the x3 direction, applied as element load. While defining the load contour, we added an option for DXF points. Now the global load contour can be defined based on the selection of DXF points. Let's see another example. This time the global load will be defined as a line load of -1.5 ton per meter length in the x3 direction, applied to elements. Select DXF points and check Chain More for continuous definition. We can see the global line load defined based on the selection of DXF points. We'll move on to the improvements in the results module. Spring stresses can be displayed as a contour map. After selecting Element Results Contour Map for the display type, a new result type, Spring Stresses, is added. We added an option for punching calculation at a wall's corner or a wall segment end. Click Punching, then select Column, and define the punching node manually. After the definition, set the default parameters. Select Single Column and select the node. The user must insert the factored shear force and the beta coefficient. Review the effective wall size for punching and revise if necessary. Click Recompute and review the detailed results. For envelope reaction display, maximum and minimum combination envelope are added. We'll move on to the improvements in the Dynamics module. When defining weights by converting static loads, a factor can be defined for each load case. And all the weights will be defined at once. At the bottom left corner of the screen, the program now displays the total weight and the weight of the displayed nodes. If we limit the display to one of the planes, we can see the total weight of 3059.2 tons, and the weight on the displayed level is 523.92 tons. When displaying the MMI and mass centers table, a new column with mass radius of inertia is added. Dynamic analysis can be performed on a selected construction stage. In the following example, we'll define two construction stages. The first stage is the hull model. We'll add another stage. We'll call it for earthquake. And in this stage, we'll deactivate all the perimeter walls of the model. Under Stages, we'll select the stage for earthquake for dynamic analysis. The result is that all static loads applied to the whole model. and the earthquake loads based on the dynamic analysis will be applied to the 4 earthquake stage without the perimeter walls. We'll move on to the improvements in the concrete design module. For reinforced concrete beams, we added an option for calculation of interface shear due to different casting times. Under Beams, Defaults, select the Shear Torsion tab. There is a checkbox for Design for Interface Shear. When checked, select the concrete surface roughness and the assumed normal stress. In the beam's detailed results, we can see the interface shear reinforcement needed at the line horizontal. For coupling beams in walls, we added the calculation of diagonal reinforcement. This calculation applies only if the walls are designed for earthquake, and the earthquake loads are classified as earthquake loads in concrete design. In the beam's results summary table, we can see a line when diagonal bars are needed. We can see the AS in each direction and the diagonal bar's angle. In the beam's detailed results, in addition to the AS and the angle, we can see the shear force taken for the calculation of the diagonal bars. Solid sections that were imported from Crosshack software can now be designed for shear. Let's look at the detailed results of a column with a hexagon shape solid section. We can see the shear design results. The section table display is improved and is similar to the properties table in the geometry module. Shear design for ordinary structure walls is now available. Looking at the detailed result of a wall section, for example between point D to point F, the shear force is 48.3 tons and the maximum allowable shear force is 644 tons. And the calculated shear reinforcement is displayed. Curved walls can now be combined to one design unit for moment and shear. The following curved wall segments are combined to a single design unit for moment and a single design unit for shear. Looking into the detailed results, we can see one result for moment and one result for shear. When checking slab detailing, displaying the elements is now optional. When clicking Check Detailing, 3 options for elements displayed are available. If Do Not Display Elements is selected, the elements don't appear for the Check Detailing contour map. Now we'll move on to the improvements in the steel design module. For the definition of steel sections, the cold form section table is now separated from the rest of the hot roll tables. When defining a cold form section, the cold form section table must be selected. In steel design, the limitation of 2 steel section tables is removed and all tables can be used. There is no need to refresh the section tables after modifications. Pay attention that due to this change, STRAP models from earlier versions that contain steel design files and will be opened with STRAP2021 will be converted to the 2021 steel design files and won't be available for older versions. The same is applied for models that were created with STRAP 2021 and contain still design files. Still design of these models won't be available for older versions. Solid rectangular or solid round steel sections defined by dimensions can now be designed in Still Design. Cold form line sections from cross-sect software can now be imported into STRAP by copy to clipboard and paste. From cross-sect, click Output, copy to clipboard, and in STRAP, define a new property and select Paste. The detailed results output is improved and includes the section drawing and local axis orientation. For composite beams or columns, the concrete parameters were moved from the defaults to the parameters menu. For composite beams, we added an option to define a stud spacing at the area of a positive moment and an option to calculate the minimum number of studs for partial connection. Now we'll move on to the improvements in the Prestress module. Interface shear calculation is now available. Under Defaults, Composite, select the interface roughness and the assumed normal stress. The program now calculates minimum shear reinforcement. When displaying the shear results table, the asterisk indicates minimum reinforcement. Under File, Setup, the default parameters may be saved for the next models. For pre-tensioned beams, the calculated development length can be multiplied by a factor. This is it for this video. Thank you very much for watching.